I've made this video for you to help you understand what's going on in this question. The first thing that we would do again is to read the information that's been given, and we note that O is the center of the circle. We see that P is a point on the circle with coordinates X and Y, and there's another point on the circle that's given to us 12 and 5. They also tell us that POQ is a straight line. And we can see that it passes through the origin, although they should have told us that. But anyway, we see that. And we see there's another point R that lies on the tangent to the circle at Q. All right, so the first thing that they want us to do is determine the equation of a circle. So now, this circle is centered at the origin. So because this circle is centered at the origin, it has to take the form of x squared plus y squared equals r squared, because all circles that are centered at the origin look like that. So there has been no shift left or right, but what we do have to do is we have to work out the value of the radius. So we would do that using distance formula. The radius we can call OQ. So distance OQ would be equal to 0 minus 12, the change in x squared, plus 0 minus 5 squared. And that would give us a distance of 13. So therefore, the equation of the circle would be x squared plus y squared equals 13 squared, which would be 169. Okay, so this question was out of 3 marks. There would be a mark for distance formula, a mark for the answer, and then a mark for writing it like that. Okay, next question, number 2.2. They've asked us to determine the equation of the straight line through P and Q. So straight away we can see that it passes through the origin. So that means that when we're working with y equals mx plus c, which is the equation of a straight line, straight away we know that c is equal to 0. So we just have to work out the gradient. We would calculate the gradient from the 2 coordinates or 2 pairs of coordinates that have been given to us. So the origin, so 0 and 0, and then q, so change in y, 5 minus 0 over change in x, 12 minus 0, which means that the gradient of this line would be 5 over 12. So therefore it has to be the line y equals 5 over 12 x. Okay, moving on to the next thing. They want you to work out the coordinates at P. What I'm going to do is I'm going to delete, I should have showed you where it would have been marked. So in 2.2, the equation of the line, there would have been 1 method mark for doing gradient and 1 mark for the answer like that. Okay, moving on. We now want to talk about the coordinates at P. Let's just delete this. You can always go back and okay. We are now at question 2.3, and what we would need to do in this particular question is we would need to solve simultaneously. Okay, so P is a point of intersection between the circle and the line that we have the equation of. So what we would have to do is solve simultaneously. So we've got y equals 5 over 12x, and we would need to go ahead and go and sub that into x squared plus y squared equals 169. So thus x squared plus, open brackets, 5 over 12 x squared equals 169. Removing our brackets, that would leave us with x squared plus 25 over 144 x squared is equal to 169. If we then multiplied each term in the equation by 144, that would leave us with 144x squared plus 25x squared equals, so that would be 169 multiplied by 144, which would leave us with 24,336. Thus, 169x squared would be equal to 24,336. We would divide both sides by 169, and that means that x squared would be equal to 144. So therefore x would be equal to 12 or negative 12. And we can see that we are working in the third quadrant. So x would have to be negative 12. Then going and subbing back in, we would get y is equal to 5 over 12 times negative 12 over 1. That's going to cancel, and therefore the answer would be negative 5. So that means the coordinates at P would have to be negative 12 and negative 5. Okay, what I'm going to do now is I'm going to delete that so that we've got space to write again. And we can now do question number 4, 2.4. Okay, so in question 2.4, they have asked us to show that the gradient of QR is minus 12 over 5. Okay, so we know that line OQ, or the gradient of line OQ, should I say, multiplied by the gradient of line QR is equal to negative 1. And that is because any line from the center to a tangent will always be perpendicular to the tangent. So our reason for that is because radius is perpendicular to tangent, like so. All right, so what that means for us is that we have 5 over 12 times the gradient of QR is equal to negative 1. So therefore, the gradient of QR is going to be equal to negative 12 over 5. We would divide both sides by 5 over 12. Okay, so in that situation there, it was just worth 2 marks. So it would be 1 mark for this and another mark for that. Moving on now to question 2.5. They want the equation of the tangent. A little bit of an odd answer here. Okay, so when they want the equation of a tangent, they want you to do that in the form y equals mx plus c. And we know what the gradient is from question 2.4. And we also know that we've got point Q that we can sub in for our x and our y. So that would be 12 and 5. So we would say that 5 is equal to negative 12 over 5 times x, which in this case is 12, plus c. So therefore, if we wanted to solve for c, we would have to multiply negative 12 with 12 over 5 and then add that to the other side. And I get a value of 169 over 5, which is a rather strange value, but anyway, y is equal to negative 12 over 5x plus 169 over 5. We're almost there. We've just got to do the last 2 questions where we've got to work out the value of t in 2.6. Very quickly, where would our marks be allocated for something like this? It's out of 3 marks, so there would have to be a mark for subbing in the point, probably for C, and then an accuracy on that line. Okay, let's rub that out and then we can carry on with the rest of it. Just 1 minute. Okay. And now we want to do 2.6. And we can see that t is the x coordinate at r. All right, so now we have the equation of the line QR. So we want to work out what t is when y is minus 1. So if we've got our equation, y equals minus 12 over 5x plus 169 over 5, what we're going to do is we're going to let y be equal to negative 1, and then we're going to solve for t. Remember, t is x. Okay, so I'm going to bring my t term over to the left-hand side. That gives me 12 over 5t is equal to 169 over 5 plus 1. All right, what I would need to do now is add 1 to 169 over 5, so that would give me 12 over 5t equals 174 over 5 Because it's over the same denominator, I can drop it thus. 12t equals 174, and t has a rather odd value of 29 over 2. Last question is question 2.7, where they ask you to determine the equation of the circle. So again, I'm going to erase this and write in its space. Let's just do that quickly. There we go. And now what we want to do is we want to work out 2.7. Okay, so if the circle has a center at 12 and 5, it means it's not centered at the origin. So it will take the form x minus a squared plus y minus b squared equals r squared. The value of a is 12, the value of b is 5, so therefore we would end up with x minus 12 squared plus y minus 5 squared. The radius is still the same because the circle passes through the origin. It means that the length of its, not a very good circle, but that means that the length of its radius is going to be the same as the other circle. So that would be 169. Okay, so here your marks would be for that bracket, and that. Anyway, I hope you found this video helpful. Good evening.